All right, time for another video here. Um, we are still working on learning, well, still on a journey of learning C++. Again, I've gone through all this information once before, but going through it a second time, I've either refreshed what I've learned or I am learning more stuff. Either way, doesn't matter because when it comes to learning, doing things over and over again kind of keeps it fresh in your mind. Sorry, I got cats playing out in the living room right now and I can hear them. Anyways, so in the last video, we finished up the rest of the if-else education that this site has to offer, and we are moving on to the examples, the real-life examples that you might use this code for, especially when it comes to what we've learned so far. There are still some parts of what we are going to do that we have not really gone through yet, but um, let's just get started. Let me adjust this screen here. Nope, that's not how it's supposed to be. Yeah, sorry. Adjusting the screen and something moved that I didn't want it to move. So there we go. So real life examples. Again, this is from W3 Schools website. Great website. If you want to learn about any kind of code, go there, check it out, see what you can learn. And this example shows how to use if else to open a door. If the user enters the code. So think of most houses nowadays and stuff, including buildings or whatnot and stuff, may have a door code to get into the building or the house or whatever. Most of the time you have to enter some sort of code, 4, 5, 6, whatever digits to get into the building. So in this example right here, this might be how the program is set up for that door code to work. Let's clear out what we have over here. Empty out the code right here and put this example in here and see what happens here. So first off, we're going to start with an integer, which is going to have a variable name of door code. And that's going to be set with a value of 1337. And then we're going to put an if statement in and have a condition door code, set it equal to 1337. So as you can see right now, obviously we've got the same thing set up from top and bottom. So if you were to set this up to where, if you were to set this up to where you need to enter something, then you actually wouldn't have this part of it here in there. You would have to have it to where the person needs to enter the code. That code would get stored in door code. Door code would be going right here. The program for the door would actually run really quick and would determine if you get in or not by a true or false statement. So, in this case though, our door code is going to match. So we are going to then either open a door or the door is going to stay locked. So you would have it to where the statement would be true, it would flip a switch, door would open, or it would be stay false, which it probably is set to false by default. Let's finish writing out this code here because we are currently working on repetition. I didn't finish that out. To learn this stuff, and the only way to learn this stuff is by continuously using it over and over and over to get it imprinted into our memory. Code dot new line. Yeah, the door is now open. So if your door actually had a digital panel that could um, print out text and stuff, it may say these things. But normally it's either you see something move, you hear something, or the door just becomes open. It doesn't normally have any kind of message screen stuff saying doors open or code or incorrect code or whatnot, but sometimes they do. So if you enter the wrong code, we got to have an else. In some cases you don't. If you don't enter the right code, it would just be an if statement without an else, and it would either unlock or lock. I mean, so you can kind of imagine this if you yeah, can imagine it. So in this case, we were using text to kind of describe what's happening. That's about the best way to say that. Yeah. New line. The door remains closed. Period. New line. And end. Go down to next. So we got the example written there. Like I said, sometimes the screen of a door block and stuff doesn't have this stuff on there. It just didn't even realize that was knocked over. Yeah, sometimes it has a screen for this sort of stuff. Sometimes it doesn't. Sometimes it just has a light, whatnot. But the idea of it is the same. You enter a code. The code gets stored into something. Could be X, could be door code, whatever. And then once you hit enter, it's going to run this type of code. It may not even be this type. If it doesn't use a C++ code language into the program, it may be something else, Python, whatnot. But it's still going to have some sort of condition. Is this the correct code? If so, go to the next code. Go to the next line of code, which is this right here. If not, there's really no other alternative. It just stays the way it is, especially if it's set to default. So we got our code. Let's go ahead and save it, run it, and correct code. Door is now open. Now, if we were to enter the wrong code by mistake, our finger slips and doesn't hit the 7, it hits the 8 by mistake. Save it, run it. Wrong code, door remains closed. So pretty simple right there. The next example. This example shows you can use if else to find out if a number is positive or negative. So let's get this one written into here. Let's clear out the terminal here, clear out this code here. Yeah, because we won't be using any of this anymore. Int my num is 10. It does have a comment there. Let's go ahead and add the comment in here. Is this number, sorry, is this a positive or negative number? That's the question mark. Now, we have the comment in there. We can see ourselves and stuff what this is, but it's not the point behind this. The point behind this is to get used to writing this code out. If, and here's the condition, my num is greater than 0, then we can go to the next line if it's true. Standard output. And yes, when I first did this, I was writing all this out just to get used to doing all this stuff and seeing it over and over again and again. Is a positive number, period. New line. All this is doing is kind of just forming a repetition for yourself. Else, practicing this stuff. We got a new condition here for if the first condition is false. My num is less than 0. output uh, the value is a negative. I keep forgetting to do that. Why is that? I don't know. Number. What I keep forgetting to do is put in the operator right here, the insertion operator. I don't know why I keep doing that either. Anyways, inline, go to the next line. Now, here's a question for you. We've got two conditions right here. Most integers can only be positive or negative. Doesn't even matter if they have a decimal or not, right? Well, we have this set as an integer, okay? But what if we change this to auto and somebody enters a letter instead of a number or a symbol instead of a number? Well, that's not going to be either positive or negative. So both of these are going to end up being false. That's where we're actually in this case and stuff, since the example is showing this, that's where it's not going to be a number at all or an integer at all. But in this case and stuff, they're showing this as this right here, output the value is 0 because it's not positive or negative. But 0 is actually considered a positive number in my opinion because negative doesn't start until you actually have a negative sign. So if it doesn't have a negative sign, then it's automatically positive. And then we got the return there. But I was more thinking along the lines of symbols and letters, because symbols and letters, yes, they have a value to them in one aspect, but in this case and stuff, they wouldn't. But we can make an adjustment and stuff and kind of go backwards in what we've learned already and play around with something like that. Especially if you're trying to get used to what the letters and symbols, ASC2 values are. In my opinion, I think most of those are positive integers still, but still. Let's go ahead and save this, run this, and we get the value is positive. We can change this to a negative right there. Save it, run it again, and we get the value is negative. So you can change this however you want. We can change this to auto. That way we can accept characters even. Let's change this to an A. Yeah, I forgot. See, this is why we do this, so we can practice with this, because we need those single quotes for this. Save it, run it, and the value is positive. Why is that value positive? Because all of our symbols that we know of are positive. Yes, you can have negative in symbols, but in this case, it's positive. This is getting turned into a value, the ASC2 value, which, if I'm not mistaken, I believe is 65. So is there any case where this would actually come true? And it's kind of telling you it can. If this value right here is set to 0, like that, and then we save it and run it, we're going to get that last response, which means that this is the only way you're going to get that last response. Otherwise, you're going to get one of these other two responses. We've already played with them in the other directions. We have learned about auto. We've learned about variable names. We've learned about integers. We've learned about conditions, if, else, pretty much all this stuff. The only thing we haven't really learned a whole lot about is this right here and these brackets right here. We know we need them, but we haven't really learned about them yet. And we haven't gotten in depth with all of this yet. And yeah, so there's a second example. Moving on to the third example. Find out if a person is old enough to vote. Well, we kind of already did this one, so do we really need to do it again? In this case, I'm going to say no. We don't really need to do it again. We've already done this example once. We've played around with the whole voting thing once before, even had inputs into a person put in their age and all that sort of stuff. So we don't really need to play around with this one again. You can if you want, just for the exercise and practice. It's not a bad idea to do that. Just to get used to the whole typing, seeing the code, all that sort of stuff again and again. It's the only way to get it formed into memory unless you are just really good with memorizing things. Some people are. Find out if a person is old enough to vote and if they are a citizen. We did this example once already before. This was where we had the if and then the nested if, especially where I was talking about in the previous video with the curly brackets being different colors. One color for the outer if, one color for the nested if. And then we have another example here. Find out if a number is even or odd. Now this one we haven't done yet. So this example we will go ahead and do. Let me clear this code out here. I'm going to start out with int my num again. Oops. Is 5 in that statement if in the condition. This is going to be something new, something you haven't seen yet. Where we're using modulus. We've seen modulus before, but we've not seen it in a condition like this. 2 equals 0. Standard output. My num. And then space is even. Notice we're kind of doing this a little bit backwards from what we normally would do. I did it again. I'm gonna get out of that bad habit here before too long. Else, and then the alternative would be standard output my num. Probably the reason why I'm doing that is because I'm not staying focused on what I'm actually currently doing. Who knows why. Dot new line end statement, and we're done. Okay, if you remember modulus, so we take whatever value, divide it by whatever, in this case this is 2. Okay, the remainder is what we're looking for. So this is going to print up, oh, don't do that. This is going to print up a remainder. Most likely modulus has got a higher priority than equal does. I haven't looked, so I'm not for certain on that, but most likely this is going to evaluate first. So if you take 5 divided by 2, how many times that goes into it? 2 times. You got a remainder of 1. This modulus symbol is going to leave 1 right here for this evaluation. Now, is 1 going to be equal to 0? No. So that's going to set this statement false, which means it's going to skip this line and go to the next line and basically print out that that my num, or 5, is an odd number. Let's go ahead and save it, make sure it's what it does print up. 5 is an odd. Okay, so if we change this to any kind of even number at all, then we're going to get 0 as the evaluated remainder, and it's going to be equal to that, so it's going to make it true, and it's going to state that it's true. Go ahead and save it, run it, and that's what we get. So there's another way of playing around with modulus. If you want to determine something else, for example, 1 is the remainder 1. So we have the 5 in there, like before. But this time it's not going to be whether it's even or odd. So you'd have to state something else right here. But we could also put in there 10. We could basically put in here whatever we want. So this is just how to use a different form. Another example, another way, seeing something new besides what we've seen before. This is example number 1, 2, 3, 4. This is example number 5 out of 6 examples. And a couple of those examples we've already seen in this, so that's why we're not doing those. Let's move on to the next thing. Last one, check temperature in Celsius. Here's a new one. Let's go ahead and get this written down here. Get rid of up to there and start typing in it. Temperature is 30 if condition temperature is less than 0, condition stated, the output for the condition, if it's true, it's freezing. Else, if second condition, temperature, because we're determining in this case, well, we haven't written it all out yet. So, I mean, it doesn't give us a lot of information on what this example is about. Temperature is less than 20. Again, this is for Celsius. So 0 is freezing, 20 is going to be cold, anything else is going to be warm, I guess. I'm not very familiar with Celsius, but I have learned a little bit about it since my computer is set to Celsius over Fahrenheit. The output, it's, come on, get it in there, right, there we go. It's cool, period, new line, in that statement, come down here, space, else, enter, then the last output for whatever remains, it's, and I'll put that in there right the first time, warm, period, new line, end statement, control save. Okay, so if it's 0 in Celsius, and not everybody may know this and stuff, it's freezing outside. It's cold enough to freeze. Basically in Fahrenheit, I think that's 32 degrees. If it's less than 0 in Celsius. If it's less than 20, it could be cool out. But the downside about it is this right here is going to end up giving us, if it's below 0, this statement is going to be true, but this statement is going to be true also. But if we remember how if statements work, once one becomes true, it ignores the rest of them for code, for the language, how this program is going to work for if statements. So once one becomes true, it'll ignore the rest of it and it'll print out the next line. So in this case, we got 30 up there. So in this case, the first one's going to be false. The second one's going to be false. So it's going to print warm because 30 is greater than 0, not less than. It's also greater than 20, not less than. So this is false, this is false. So let's change this right here value to 10. Control save, print. And it's cool. It's 10 is still greater than 0, so it's not less than. But it is less than 20, so this statement becomes true, so we print out this one right here. Now, what if it is 0? We don't have anything for that one. Save, run, it's cool. Because it is 0, so I guess we do have something for this one. So it's not equal to 0, but it's not less than 0 either. So therefore, this one becomes false because it's not less than and it's not equal to, and we don't have the option for equal to. So it still becomes cool because this. That one probably is obvious to you guys and stuff, but I kind of had to see it myself to see what the obviousness was in it. Realizing that the operators are what I was not realizing. I must be a little out of focus right now and stuff. Could be because it's late, or it could be because I just got done eating or whatnot. But yeah, so you would actually have to set it to a negative amount in order to get the first statement to become true. And now it's freezing. Any negative amount and stuff will make the first one true. Anything between 0 and 20, or 20 to 0 to 19 will make the second statement true. Anything above 19 is going to make the third statement true. So you have a range there. Below 0, this one, 0 to 19, the second one, above 20 or 20 or above, this one right here. All right, that's the end of those right there, the examples for that. The next section we have is the condition code challenge, basically just writing out code. You can do this if you want. I'm not going to do these right here. Just because I don't really need to try and write code, I need to see more code to understand it. It's not about trying to write some code and stuff to get it to work. It's morely about seeing the code and understanding the code first. Basically exploring the code before I try to start writing my own code. So I'm going to skip that and we're going to move on to switch. This one is probably, I'm just looking through here. Okay, so we can go through this one right here in the remainder time of this video right here. And then when we get to the while loops and stuff, that's when I'm going to switch over to another video. I'll go ahead and label this one as switch as well. Examples for, yeah, I'm not going to do even examples because those were kind of lame examples for if. I mean, they were more the exercises more than they were examples, in my opinion. But that's for me. If you're first time seeing this, then do those examples, get used to writing the code out. And then trying to explain it to yourself on why this does what, just like I'm doing right here. But let's switch over. Let's go to switch. C++ switch. C++ switch statements. Use the switch statement to select one of many code blocks to be executed. So with if the first condition was true, we just printed out the first one. With switch, according to this, we are looking for a statement that is true. Use switch statements to select many code blocks to execute. The syntax for this and stuff looks like this. So you're going to have the keyword switch. I think it's the keyword. We don't have a space in here. We have an expression in parentheses. Tab, case, X, colon. It's not even really going through what all this is. I don't really like that, but it is what it is. Put another space in there. Code, block. It may explain this later on. I don't know, but tab, case, Y, code, block, tab, default. I have a feeling it's not going to explain that one either because we haven't seen a lot of these keywords yet. So this is all going to be new stuff to us. Code, block. Oops. Okay, so that's the end of that. This is the syntax for it. So you have a switch, you have an expression. And you have case X, case Y, and then default. If case X, I can explain this to you, but I would prefer for this to explain it to you and me just read it off to you. This one right here, I morally trust this over what this is going to say. But let's see what it says. This is how it works. The switch expression is evaluated once. The value of the expression is compared with the values of each case. If there is a match, the associated block of code is executed. The break and default keywords are optional and will be described later in this chapter. This example below uses weekday number to calculate the weekday name. Okay. So we're going to go ahead and scratch all this code right here. Put an int day. Just pretty much put this code in here. Switch. Before I explain any of this, day case 1, standard output Monday, break. Let's go ahead and do that while it's doing that. That tab, enter, delete, backspace, case 2, colon, enter, tab, standard output Tuesday. Make sure I'm spelling that right. No, we don't want a tab. Yeah, that right there. Enter, break, case 3, colon, enter, tab, standard output Wednesday, break, enter, backspace, case 4, tab, standard output. This one be Thursday. I gotta kind of look to make sure I'm spelling these right. Break, backspace, case 5, enter, tab, standard output Friday, break. Now, as it said before and stuff, some of this you're going to kind of just ignore because it hasn't gone over it yet. Other parts you're going to pay attention to, and it'll probably go over it later on. Right now, we are just copying the code. I'm going to do my best to kind of Saturday explain this. Like I said, I don't agree with the way it's explaining this, but it is what it is. Case 7, standard output Sunday, break. And then it's got what the output should actually be. So here's what this is doing. Okay, so we have integer day 4. Okay, so the switch is going to be day. So this goes in here. So whatever. So it's day 4. The compiler is going to look through each one of these cases to find out which one day matches up with. And since it's 4, it's going to match up with this one and print this one. If it doesn't match it, it's not going to print it out. So since day is 4, case 1, 1 is not 4, so those don't match. So it's not going to print that one. Same thing with this one. 2 is not 4. 3 is not 4, but 4 is 4. So think of this as which case is this? And since day represents 4, we're going to go through here and find case 4 because that's what this matches. That's how a switch works. Jump, 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 or switch one case to another until you find the expression that matches. Or in this case, the integer that matches, which is 4 up here, 4 down here. So then it's going to run this. Again, what it's not explaining is what this is right here. It's not doing a very good job of explaining case at all right off the bat. Or switch. It's just giving you an example right off the bat without explaining any of this. When I did this, I think I was lost for this. I think I was trying to guess at what it was doing and just hoping I was right. Okay, so let's keep going on through this. The break keyword. So we're going to jump straight into this right here. Actually, let me read this back here again. The switch expression is evaluated. So this is the expression right here. In this case, it's not a condition. It's an expression. There is a difference. The condition first has to be evaluated. In this case, the expression has to be evaluated, which there's no evaluation to do since day is 4. Uh, like I said, I don't really like the way this is set up for this. The value of an expression is compared with the value of each case. So we compare day with each case, which is 4. So 4 compared with each one. And since it matches this one right here, that's what we print out. If there is a match, the associated block, which is his associated block for this code right here, is executed, which means it's going to print Thursday. The break and default keywords are optional. I don't agree with that statement, but let's go with it for now, and will be described later in this chapter. Okay, so we have saved this code. We will run it, and it will print up Thursday because 4 matches what the day is, 4, and that is, so it runs this block of code right here. Let's continue on with this. The break keyword. When C++ reaches a break keyword, it breaks out of the switch block. So when it gets this, it jumps out of the sequence. So think of this as one entire block of code. Okay, we're stuck in here until we get out. How do we get out? Well, that's what this is supposed to be for. Break. Break the code, get out of it. Go to the next line. In this case, it's return. I don't 100% agree with the way they have that worded either. I've seen this already in somewhere else and stuff, and I think that they do a better job of explaining this because I was still confused when I was looking at this and still guessing when I was looking at this the first time around. Okay, so C++ reaches a break keyword. It breaks out of the switch block. This will stop the execution of more code in case testing inside the block. So once it reaches this right here, it runs this code. It's gonna, like I said, it doesn't match this one, so it's gonna ignore whatever's here. It doesn't match this one, so it's gonna, and it's just gonna keep going until it matches one. Once it matches one, it's gonna run this code first, obviously printing out Thursday, and then it's gonna go to the next line, run this code right here. If this wasn't here, it would actually continue running code until it found a break or until it got to the end of the sequence, and then go to the next line. So if we remove break, 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 and come to here, it's going to continue running all these. And let's play with that. Let's play with that. So we're going to get rid of break right there, break right there. We don't need that either. Break right there, break right there. Now, if I'm not mistaken, even though it's going to run Thursday, it's also going to print out Friday, Saturday, and Sunday because it's not jumping out of the switch. It's not breaking. It's going to run all of them. It matches this one right here, but because it's going to continue running after that, it's going to run all 4 of them, even though it doesn't match these. Yep, Thursday, Friday, Saturday, Sunday. That's why I say I don't like the way it words this because that's not exactly, I mean, it is what break is doing, but it's not a very good description of it. In my opinion, break, it stops from running it stops it from running the switch anymore. Checking cases. In fact, it tells it, you know what, you ran this right here. We're done with the switch. Let's move on to the next thing past the switch. Break the switch, sort of thing. Like I said, there's another website that describes this so much better than what this does. Anyways, so yeah, we just basically, I mean, we match this up with this. It's also matching with this, but without that break keyword in there and stuff, it's just going to keep running the sequences and keep going down the line. Break has an actual word to it. This probably has a better meaning for it than what this does, but anyways, you understand the point right here. I hope. When a match is found and the job is done, it's time for a break. There is no need for more testing. A break can save a lot of execution time because it ignores the execution of all the rest of the code in this switch block. That's a better explanation for it, but Still not enough, in my opinion. I understood it when I did this the first time. I just like the way it's described in other sites better. The default keyword. The default keyword specifies some code to run if there is no case match. So in this case, we only got up to 7. So what if we had an integer 8 in there? Like this. We save it, run it. We don't get anything. Nothing matches. Well, what if you want something to print out of the switch? That's where you would use the default. It doesn't really specifically say that. It actually has another example in here. Let's go ahead and do the example real quick. I know we kind of skipped it, but still. I just don't like the way it describes how this works. So we're going to get rid of all but 2 cases. In fact, we're not going to do it that way. We're going to remove all but 6 and 7. So we're going to remove all this right here. There we go. I knew I was doing something about that. There we go. Okay, we're going to go ahead and add the break back in so that works properly. Okay, now this matches. We got 6 and 7 in there. Matches the example anyways. After this, we're going to go to a default. Default will line up with the case. This is the code to be executed no matter what. As if there's no case that matches, then something will run. Basically putting default in there just basically means something out of the switch will run. Standard out looking. By the way, in the comments and stuff like that, you can, if you want to throw in a better explanation of break and how switch works in the comments, feel free to. Like I said, I don't really like the way it describes a switch or break. There's a lot more to this than what it's actually really saying. In fact, you can do so much more with a switch than what it's referring to here. So in the comments, if you want to throw that in there, go right on ahead. I will eventually later on when I get to the next source, which my next source is going to be learn CPP. After I finish up all this source, we're going to go back into break again eventually and probably have a much clearer understanding of break and many more examples of how it can be used. Switch has a lot of options, just like if statements, else statements, if else statements, so forth, so on. But for now, yeah. Looking forward to the weekend. And in this case and stuff, so today is, I'm going to add this in there because it's in this example right here. Today is, so this is presuming that, and we're going to go ahead and put this back to 4 here. Like that's everything pretty much. Save it the way it is. So this is presuming that it's Monday through Friday, somewhere around there. We know that previously and stuff this was Thursday, but we got rid of that example. We're placing another example in here. So we're presuming that this day represents somewhere between Monday and Friday. So when you run this code, since it doesn't match Saturday or Sunday, it's running the default looking forward to the weekend. So it's Monday through Friday, somewhere in there, looking forward to the weekend. So we've already saved it. Let's go ahead and run this. And since 4 doesn't match any of the cases and stuff, it's running the default. Default will always be the last option in this. You don't want it to be the first option. You want it to be the last option in this. You do always want to have break in each case though, which is not something it says. In fact, it says that break and default is optional. And yeah, it is optional. Um, in the time that we had Monday through Friday up here with no default, if you want to go ahead and leave breakout right there and have it run, yeah, today's Thursday, Friday, Saturday. How can it be 4 days? That's why I don't like, yeah, it's in that opinion, in my opinion, it's not optional right there because otherwise you're just saying it's Monday, it's Thursday, Friday, Saturday, Sunday. It's 4 days. It's not 4 days. It can only be one day. We only live one day at a time. We don't live 4 days at a time. That would be terrible, I think. Living 4 days at once. Uh, I'm not sure I can handle that. Anyways, that's my imagination going wild right there, thinking that 4 days, living 4 days at one time is actually possible. I wouldn't want to try that even. Also, the fact that they didn't use a default in the first place and stuff, allowing anybody to put whatever they want to in for an integer and stuff, and then not having anything print out because they put 8 in instead, is a fault. In my opinion, you're going to get undefined behavior, but I think we've kind of went on and on enough about switches and stuff. Like I said, I don't agree that there's enough information here about switches. I think that they need to go through a lot more because they say that they make this switch seem so simple, like there's nothing to it. And that's not true. There is a lot more to switches. In fact, break is not even the only option for switch. But it doesn't say that in here anywhere. It doesn't mention it anywhere. It doesn't even have a reference guide to all the rest of the code that can go into a switch. So for now, we know about switch. Do we have details on switch? We have a few. I would say 25% of the details on switch. That's it. Can you write code with this? No. I wouldn't know. Your code's not going to work very well just writing it this way right here. You need to know everything about Switch in order to be able to write code for Switch. It is a very powerful tool, just like if, else if, and everything else that we've been learning. But you know about it. That's the important part. So I think we're going to end the video right there because I went through that quite a bit and stuff, especially since I don't really agree with what they have in there. I think there's a lot more that they could have supplied in there. And maybe, yeah, if they got some help with supporting the website and stuff, they might put some more in there. But for being free, this isn't too bad. Will it? Will you be able to? I think that's. No. Okay, so I see a section right here and stuff where it says break continues. So maybe they get more detailed into Switch later on in the educational part of this. Maybe. I don't know. But why would you not put them together? I don't know. But again, since I don't support the website and stuff, mainly because I just don't have the money to support it, um, I it's still a great website. It still works. It still shows you a lot of stuff. The code challenge we're not going to do. In fact, in the next video and stuff, we're going to start in while loop. Loops are also very powerful. So you've seen two things right now where you have multiple scenarios of stuff. Switch, if, else if sort of thing, and then a ternary option thing. Well, while loop and stuff is going to be a third option. But we're not going to get into that in this video. Again, like I said in the comments, if you want to make any comments about anything so far in this, go right on ahead. Um, I don't disagree with this website. I don't 100% agree with it, but this is where I started. I got a lot of education off of it, so I think it's very useful for a beginner. Go through, read the stuff, do the exercises, type them out, try to understand what you're typing out. If you don't understand it, that's fine. Just keep going through it. Don't stop and try to say, well, I'm completely confused. What this doesn't make sense. Don't stop. Just keep going through it even if it doesn't make sense. Do the exercises, read the material. Once you get all the way through this and stuff, you might want to try to go back through it again. That might help, especially since they mix things around. Like I can see break and continue right here, so I do a better explanation and maybe explaining break later on. And continue, I can't remember if I do or not. But once you go through this once and stuff, then maybe move on to another site. I mean, I suggest this site right here. I'm going back through this site right here, and a lot of this stuff does make sense to me now because I've gone through this once before. I've gone through a lot of this already, sort of thing. Like I said, comments are out there. Post them, answer questions, ask questions. If there's something I said and stuff that is incorrect and stuff, and somebody's trying to learn off of it, correct it. That's fine by me. I'm not trying to educate, I'm just trying to show my journey. So, and I've got a lot of resources, a lot of information, and yes, I may have quite a few videos out there already, like 20. This will be video 21 with 20 plus hours in this. But I've spent well over the 20 hours in learning about C++, and I still don't have it all learned. I still don't fully understand it. I cannot write a complex program with C++ yet, but that's fine. I'll get there. I'm still learning stuff, even going through this basic stuff right here. So. Otherwise, I hope you enjoyed the video, and I will see you next time. Probably tomorrow for me. Actually, it is tomorrow for me, but yeah, I probably won't make any more videos tonight. I'll probably get some sleep and then make some more videos starting in the morning. So, have a good day.